This example is a trig equation that is quadratic in form. Here we're given 2 cosine squared x minus 3 cosine x plus 1. A good thing to do with a problem like this is to make a substitution and say let u equal the cosine of x. We can make a substitution here to get 2u squared minus 3u plus 1 equaling 0. Once we factor this will factor into 2u minus 1 and u minus 1 as well. So if you can check this out by foiling if you'd like. 2u squared on the inside, a minus u minus 2u will give us a minus 3u. Negative 1 times negative 1, that's our equation. The problem here is we don't want our equation in terms of u, we want that in terms of the cosine. So let's rewrite this when we resubstitute so that we have 2 cosine of x minus 1 times the quantity cosine of x minus 1 equaling 0. And from this we have a factored left-hand side. We can break that up into our two equations of the form 2 cosine of x minus 1 equals 0, and then also the equation cosine of x equaling a negative 1, actually rather a positive 1 once we move that 1 to the other side. So let's focus on the first equation. We have the cosine of x is equal to 1/2. Note that our cosine value here is positive. That's greater than 0. And because that's greater than 0, we have to address the cosine solutions in quadrants 1 and also in quadrants 4. So let me write that in here, quadrant 1 and quadrant 4. Now, as we look at this, when the cosine of x is equal to 1/2, we obtain a reference angle of pi-thirds radians. And in quadrant 1, we know our solution will be x is equal to pi-thirds, since the reference angle is, in fact, pi-thirds. And then in quadrant 4, our reference angle gives us a value of 5 pi-thirds. And again, you can check this on your calculator. Cosine of pi-thirds will give you 1/2. Same thing with the 5 pi-thirds. Okay? Now we want to address the periodicity by adding 2 pi n to both of these, knowing that we have an infinite number of solutions for these particular equations. Now, let's focus our attention on the equation cosine x equals 1. We know that this happens when x is equal to 0 radians, and again, addressing the periodicity, we'll add 2 pi n. Now, the one hang-up we have is that our solutions are to be between 0 and 2 pi radians. So when we plug in 0, n equals 0 rather, into all three of our potential solutions, we come up with the three solutions, pi-thirds, 5 pi-thirds, and also 0. Those are the three solutions between 0 and 2 pi. Note that if we plug in 1 or a negative 1 for n, that will take us outside our interval. So we've done it. We have our three solutions to this trigonometric equation that is quadratic in form.